Again, this is time for previous year questions. So let's start with your sleeves up to see how much you can score and how is your preparation till now. Right? Let's start doing the questions. The first question, as you can see, it has come in JEE 2019. Two blocks A and B of masses 1 kg and 3 kg are kept on table as shown. Upper block is of mass 1 kg and lower of mass 3 kg. Coefficient of friction between A and B is 0.2 and between surface of table and B also it is 0.2. Okay, so it has the same value of friction between these two surfaces. The maximum force F that can be applied on B so that A does not slide over the block B is. What does it mean that block A is not sliding over the block B? They two must be having the same acceleration. Then there will be no relative sliding between the blocks. So let us start doing the question. Now if we write for this whole system, then A can be written as net force on the system that is equal to F minus F1. Here I am writing friction as F1 between block B and the table surface. This is F minus F1 upon MA plus MB. And this friction F has to be equal to, that is mu into normal reaction at these two surfaces. So it has to be equal to mu multiplied with MA plus MB into G. So we got A is equal to F minus mu MA plus MB multiplied with G and whole divided by MA plus MB again. This is the acceleration we got. On substituting numerical values, we will get A is equal to F minus 8 upon 4. Now due to acceleration of block B, a pseudo force will act on A. I am writing with respect to B, so we have to consider pseudo force as well. And what is the pseudo force here? It has to be in this direction. Let that be F dash. And of course, friction has to be there. Let this be F2, because when B starts moving in rightward direction, A will oppose it and A will apply a friction on B in left direction. In reaction to that, B will apply friction on A in right direction, that I have written as F2. Now this F dash can be written as, because it is a pseudo force, so it can be written as mass of A into acceleration. Here it should be acceleration of B, but since both are moving with same acceleration, so directly I am writing acceleration A. Now if A has to slide over B, then pseudo force on A must be greater than friction between A and B. So first I am considering the limiting case that F dash is equal to F2, so that it has not started sliding yet. So it will give the equation we will get as MA A is equal to mu MAG. And on solving the numerical values, it can be written as A is equal to mu G, that is equal to 0.2 into 10, which is 2 meter per second square. This value if we put in our equation for acceleration, then it can be written as 2 is equal to F minus 8 upon 4. And from here, F can be written as, this will come out as 16 Newton. So this is the maximum force which if applied on lower block, the upper block will not slide on the lower block. They both will move together. Let's move to next question. Again, this is from JEE 2019. A block kept on a rough inclined plane, as it is shown here, remains at rest up to a maximum force 2 Newton down the incline. The maximum external force up the inclined plane that does not move the block is 10 Newton. Both cases are given there. When external force is 2 Newton down the incline, then it remains at rest. And also if upward force is 10 Newton up the incline, then also it is not moving. So we have to calculate coefficient of static friction between the block and the plane. Both the cases we have to solve separately. So let's start with case 1. When 2 Newton is being applied in downward direction. Now if you see what forces are there in downward direction, here I am writing case 1. When 2 Newton force is applied, so what forces are there? Forces are in this direction, it will be 2 plus of course one component of mg, that is mg sin theta. In this direction it will be mg cos theta. Opposite to this has to be normal, and opposite to this downward force has to be friction. And since it is in equilibrium, so we can write 2 plus mg sin theta is equal to F, or 2 plus mg sin theta is equal to mu n, where n is equal to mg cos theta. So directly I can write this to be mu mg cos theta. So this is our equation number 1. The next case we have to consider when a 10 Newton force is applied up the plane. So if we write that condition, it will be like this. In upward direction is 10 Newton force. What other forces are there? In this direction as previous, it has to be mg sin theta, normal, then mg cos theta, and friction force has to be there. Now it is saying that maximum 10 Newton force should be applied up the plane. So friction also should be in downward direction along the incline. Now if we equate the forces, because again the block is in equilibrium, we will get mg sin theta plus F is equal to 10, or mg sin theta, again we can write F as mu mg cos theta, so plus mu mg cos theta is equal to 10. Now if we solve these two equations, we will get mg sin theta is equal to 4 and mu mg cos theta is equal to 6. On dividing, it will give mu cot theta is equal to 3 by 2, or we can write mu as 3 by 2 cot theta. On substituting the value, because theta is provided here, it will come out as root 3 by 2. So mu, we got the value of coefficient of friction. It has to be equal to root 3 by 2 to satisfy both the condition when a downward force is applied and when an upward force is applied, having magnitudes 2 Newton and 10 Newton respectively. The block is not sliding at all for both the forces. Let's move to next question now. A block of mass 10 kg is kept on a rough inclined plane as shown. It's shown here. A force of 3 Newton is applied on the block. The coefficient of static friction between the plane and the block is 0.6. What should be the minimum value of force P such that the block does not move downward? Okay, so let's write free body diagram for the block. Just show all the forces here. In vertically downward direction is mg, one normal here, other forces being 3 Newton along the incline down. This is external force P up the incline, and one friction will be there. Now since it is asking for minimum value of force P, so that friction should be in direction of P. If it would have been the maximum value of P, then we had to apply this F along the direction which is down the incline. Here it is asking for minimum value, so this friction has to be in upward direction in the same direction as that of P. Let's now write the equation. We have to write along the incline net force to be 0 because the block is in equilibrium. So we can write 3 plus mg sin theta minus P minus F is equal to 0. As frictional force we can write as mu into N, and N as we can see directly can be written as mu mg cos theta. If we substitute this value in above equation, it will give 3 plus mg sin theta is equal to P plus mu mg cos theta. If we substitute all the numerical values, we will get P is equal to 3 plus 100 upon root 2 minus 60 upon root 2, that is equal to 3 plus 40 upon root 2, which will give 32 Newton. So which option is correct? This is option number 1. In next question, two masses M1 and M2 are connected by an inextensible string, as it can be seen here, over a frictionless pulley, and are moving in direction as shown. The coefficient of friction of horizontal surface is 0.15. The minimum weight M that should be put on top of M2 to stop the motion is. Okay, so initially this M1 is coming down and the block is coming towards right, but we have to calculate the value of M so that this motion is stopped. Let's start the solution. What friction will be acting here? It has to be mu multiplied with M2 plus M multiplied with G. So it is the resultant friction force here, which of course will be acting in direction towards left. So if the system is not moving, then we can write T should be equal to M1G for the hanging block. And for the system of block which is on the surface, we can write T should be equal to the friction force, and that is equal to mu M2 plus Mg. On equating these two values, we will get M1G is equal to mu M2 plus Mg. And since all other values are provided, we can directly write the value M to be equal to 23.33 kg. Just substitute all the numerical values and you will get it. So this is the minimum weight that should be put. Of course, all the mass that is more than this will stop the motion of blocks. So it has to be the minimum mass, that is equal to 23.33 kg, which is our option number 1. Let's proceed. A uniform wooden stick of mass 1.6 kg and length L rests in an inclined manner on a smooth vertical wall of height h, such that a small portion of stick extends beyond the wall. Okay, so it has to be height of wall is somewhat less than the length of stick, and stick is put in this manner. So some portion is beyond the wall. This is the stick of length L. Up to here is the wall. Height of wall is provided, that is equal to h. L is the whole length of stick. Now we have to write the ratio h by L and friction force at the bottom of stick. The other assumption that we have to make is that reaction force of wall on the stick is perpendicular to the stick. So it has to be this reaction force which is perpendicular to the stick. Let us denote this by N1. One normal will be here by the ground. Let that be N2. The stick is making angle 30 degree with wall. So if this is 30 degree, it can be written as 60 degree. Now Mg will act just at L by 2. So this is our force Mg. All the forces I have shown here now. If this stick has to be in equilibrium, then we can write in x as well as in y direction net force to be 0. Let us consider this as x and this as y direction. First I am writing summation of fx to be 0. What forces are there in x direction? This is N1 cos 30 degree minus F, because this stick will try to slide against the horizontal surface. So one friction has to be there which will be in this direction. So this is the direction of friction force. Now I am writing equation in x direction, which is N1 cos 30 degree minus F, and it has to be equal to 0. If we write in vertical direction, that will give N1 sin 30 degree plus N2 minus Mg to be equal to 0. Now if we write torque about this point, let that point be O. So next I am writing torque about O. The rotation is not yet started, but still you must be having some initial idea about what torque is, how it can be written. It has to be force multiplied with the perpendicular distance from the point about which we are writing the torque. So I am writing torque about O. It has to be equal to 0 for rotational equilibrium. So net torque I am writing about O to be 0. Now what this torque will be? For weight, it should be equal to Mg L by 2 cos 60 degree minus N1 H upon cos 30 degree. That should be equal to 0. I haven't written any torque for N2 because N2 is acting at O itself. Friction also is acting at O itself. So no need to write the torque for these two forces. Now if we solve all these three equations, One more condition is provided here, that the reaction of wall on stick is equal in magnitude to reaction of floor. So it is given that N1 is equal to N2. If we solve all these equations, we will get H by L to be equal to 3√3 upon 16 and F, that is friction, is equal to 16√3 upon 3. So our correct options are option number 4. Let's now move to next question. Given in the figure are two blocks A and B of weight 20 Newton and 100 Newton respectively. These are being pressed against a wall by a force F as shown. If coefficient of friction between the blocks is 0.1, here is the coefficient of friction given, that is equal to 0.1. Between block B and wall it is okay. Here also friction is there, that is equal to 0.15. The frictional force applied by the wall on the block is. Now if we write free body diagram for block A, it will be equal to what forces are there? This is the external force, then the friction. Of course it will try to slide down due to its weight, so an upward force has to be there, that has to be friction. So this is friction. Weight is there in downward direction, which is equal to, its weight is given 20 Newton. So this is 20 Newton in vertically downward direction. And one reaction force, one normal force by B on A. So that has to be equal to N1 I have written here. Now if we draw free body diagram for B, what forces will be there? This N1 which is by A, its weight, this weight is given 100 Newton. B had applied a frictional force in upward direction on A, so A will apply a force, frictional force, that is in downward direction having the same magnitude. Now due to action of these two forces, 100 Newton and F1, it will try to slide down the wall. So wall will apply a friction in direction upward, that is F2 I have written. One more normal will be there by the wall, let that be N2. So these are all the forces applied on A and on B. Now I am going to start writing the equations. From the FBD of second block we can write F2 should be equal to F1 plus 100 Newton. And from first block we can write F1 is equal to 20 Newton. So if we substitute this value in above equation, F2 will come out as 120 Newton. This will be our correct option. Do remember one thing here, in this question do not write F1 as mu N1 or F2 as mu N2, because it is not always necessary that friction force, it is a static friction here. So it is not always necessary to write static friction force is equal to mu into N. First we have to check what is the external force. If it is more than static friction force, then only we have to write the value of friction force as mu N. Otherwise it will be equal to external force only. So here the question is solved with help of external force being equal to that of friction. Again one question we have, a nucleus emits particle with velocity v. Find the recoil velocity of nucleus, and different options are given here. So let us calculate the recoil velocity. Now you can recall the concept of momentum conservation. A nucleus, if initially it is at rest, its momentum has to be equal to 0. It should be alpha particle here. Initial momentum has to be 0. So we can write initial momentum to be equal to final momentum, because this emission of alpha particle is an internal process. There is no external force applied on the nucleus. So if initial momentum is 0, finally also it has to be 0. Now if we write the final momentum for alpha particle, it will be 4 into v, because it is moving with velocity v. Mass of alpha particle can be written as 4. I am writing taking reference as mass of proton, that is 1. So if 1 atomic mass is taken as reference, then mass of alpha particle can be written as 4. So this is 4v plus Now the remaining mass will be equal to A minus 4, where A is atomic mass number of that particular nucleus. So this be V dash. From here we got V dash to be equal to 4V upon A minus 4. One minus sign will be there, but then it is asking for recoil velocity. So always it should be positive. Only its magnitude to be taken. That is our option number 1. In next question, sand is being dropped on a conveyor belt at the rate of m kg per second. The force necessary to keep the belt moving with a constant velocity of v meter per second will be. It is a question that is related to variable mass system. Now let us see how this can be solved. We have to calculate the force. So force can be written as d of mv by dt, which is rate of change of momentum. That should be equal to v dm by dt plus m dv by dt. But here it is mentioned in question that it is moving with a constant velocity v. So this term will reduce to 0. That is equal to v. And what is dm by dt here? It is given that mass is changing at a rate of m kg per second. So that is the value of dm by dt. If we substitute here, F will be m into v Newton, which is our option number 1. In next question we have a gramophone record is revolving with angular velocity omega. A coin is placed at a distance r from center of the record. Let us draw the situation. If this be center of the record, the coin is placed at a distance r from here. The static coefficient of friction is mu. The coin will revolve with the record if. Now see, to revolve it must be having some centripetal force. Can you see any force that can provide it the necessary centripetal force? Can it be weight? Can it be normal? No, because these are vertical forces and this centripetal should be in horizontal direction. So the only remaining force should be friction. And as you know that static friction is a force which is a self-adjustable one. Whenever need arises, this friction comes into picture. So here friction force must be the force that is required to provide it the necessary centripetal. So we can write this friction force should be equal to m omega square r. But what is this Fs? Fs can have maximum value to be equal to mu n. So it can be written as, because Fs should be less than equal to mu mg. So from here we can write that this m omega square r should be less than equal to mu mg, and we will get the situation m omega square r to be less than equal to mu mg. If we solve it, it will come out as omega square r less than equal to mu g, and r is less than equal to mu g upon omega square, which is our option number 3. So this is correct. A person of mass 60 kg is inside a lift of mass 940 kg. Let's first draw the situation. The man is having mass 60 kg. This is 60 kg here. And lift has mass 940 kg. The lift starts moving upward with acceleration 1 meter per second square. A is given for the lift, that is 1 meter per second square. It is asking for what is tension in the supporting cable. Okay. So if we write for this whole system, then tension minus the resultant downward force, that has to be equal to 940 plus 60 g, because this is the resultant weight in downward direction, and it should be equal to mass into acceleration, which is 940 plus 60, that is 1000 A. If we substitute the numerical values, it will come out as T is equal to 940 plus 60 g plus 1000 A, which will be, if we write G as 10, then it will be 10,000 plus 1000, that is equal to 11,000 Newton, which is our correct option. With this, our session of previous year questions also completed. Next, we will move to the next chapter, that is in your NCERT book, which is work, power, energy. Let's see forward to it. Goodbye.